Hello, test. Done. All right. Good evening, everyone. So this is day 2 and week 2 of deep learning. And today we'll be getting started with MLP, that is multi-layer perceptron or artificial neural network. Perceptron, artificial neuron, both are synonymous. So we will dive into how we can use the value class further to compose neurons and also different layers of neurons, because that is the main essence of a neural network. So far we are dealing at only a neuron level, but a neural network is composed of several layers of neurons. So that is exactly what we target to explore and understand in today's session a little bit, but mostly the forward pass. Backward propagation, gradient descent will not be covered in today's session. So we'll build upon value class, we'll introduce few more classes as well and mimic the forward propagation or the forward pass step in a neural network or an MLP. So that is the agenda of today's session. And yesterday, to give a quick recap of what we discussed, we understood what happens in the case of a multiple node connection. If a node has one or more than one connection, then we fixed our code in order to accumulate all the gradients. That was exercise 1 yesterday. And exercise 2, we drew parallels between PyTorch and the value class. We saw how we tried to mimic exactly what PyTorch is providing us through its library in the form of tensors, in the form of backward method. So we understood how the method signatures are different, but yet how did we try and mimic exactly what PyTorch is doing or what PyTorch is providing us out of the box. So that was about yesterday, and today again, to reiterate for those who joined a little late, we'll be dealing with neuron and layer specifically in today's session. So today, first we'll begin with handling type conversions in value class, because we did not do any kind of value handling or type conversions. So we will see where there is a flaw in the value class, we'll figure out, we'll try to raise that bug intentionally and then see how we can fix it. So that is the first thing we'll do with an in-class activity. And then we'll get started with MLP. I will introduce neuron class. While I do the live coding, you also please do the same code at your end using the practice notebook. And besides neuron class, we'll be introducing a layer class as well. So this will complete the picture of a neural network. So all of these classes that we are going to introduce, the two of them, that is neuron and layer class, they will be using value class. So it is not like we are disposing value class completely, we still have dependency on value class. But we'll see how we are adding that dependency one at a time. So that is all about today's session. And coming to handling type conversions in value class. So I will show you how we can surface this bug. There is a serious bug in our code, so we'll understand how we can surface it and how do we reproduce that bug, understand why this bug is coming and where is it coming from, then we'll fix it. So we'll use the existing value class, whatever you completed till yesterday, that is exercise 1, because exercise 2 was on PyTorch tensors. Exercise 1, you changed the code, you modified the logic in order to accumulate the gradients correctly. So we will use the same code up to that point, and then we will start looking at the bugs and fixing them one by one. So we know that this is how we initialize values using the value class. A equal to value 2.0 with a label A. This is all good. And if we print A, it shows the representation. Whatever we define in the representation, it returns that as the output. But what happens when you try for A plus 2? So first initialize value of A, print it, in the next cell, try running this code that is A plus 2 and tell me what is the output. What is the error? What does it read? No, what is the last line specifically? So your friend says he's getting an error when he tries to run the cell which has A plus 2. So I want to know what is the error message. Can one of you read it out for me? So what is the error message? I want the complete error message, that one line, last one line. Int object? Int object has no attribute data. So you all are getting the same error? Yes. So int object has no attribute data. Now try 2 plus a. What do you think should be the output? Unsupported operand types. So different error, right? So where are the two errors stemming from? First one is an attribute error, second is a type error. So where are these errors coming from? What is happening in the first case and what's happening in the second case? That is happening in both the cases. I'm asking specifically for a plus 2. For a plus 2, why do we get an attribute error? And for 2 plus a, why do we get a type error? So you're saying, where is this error coming from? Which class is throwing the error? Attribute error for a plus 2, it's being thrown by value class. And what about 2 plus a? Integer. So why do you think this is happening? Shouldn't it be the same error in both the cases? So what do you think is happening? Logically, what do you think is happening? In case of a plus 2, 2 plus a, what's the difference? Yes? You want the mic? You can look up for information on the internet. Give me a relevant answer, that also works. D underscore? Correct. That is for attribute error. We understood. It's not able to handle. But my question is, in the second case, why do we get a type error and why not attribute error? Integer? Okay, you're almost close, yeah. So you're saying for 2 plus a, since integer is first, it's expecting the next value to be also of type integer and not value. So that's the reason we are getting a type error in that case and not attribute error. Any other answers? Or you agree with him? Alright, so that is the answer. But I want you all to look up for a method where we can correct this. So basically I want to get the same error. Either when I do a plus 2 or 2 plus a, I want to see the same attribute error. I don't want to see the input, the type error. A plus 2 or 2 plus a, in either cases, I want to see the attribute error and not type error. So what do you think is a change that we can do? Not possible? Look up, you can look up for information on Python documentation, read about the D underscore addition. Are there any similar methods like D underscore add? Any method which is equivalent to D underscore add in Python. The magic methods, that it's usually called that way, the D underscore methods, the magic methods in Python. Now I'm interested in getting only attribute error, no matter I use 2 plus a or a plus 2. So what do you think should happen in that case? And the hint I'm giving you is look at the d underscore method that Python provides. Remember, we are overwriting the d underscore addition method, underscore underscore add underscore underscore. So is there any method which is similar to that which we did not implement? No? ChatGPT is not helping you? Or your prompt is not good enough? No answers? So this is also a short in-class activity just to guide you on how you should look up for documentation. Okay, so yeah, that's the correct answer. Your friend says it's double underscore r add. And what does the definition read? Self comma other. No, in the API documentation. What's the purpose of r add and how is it different from add? Sorry, right hand side. Right. So there is a d underscore method which is called r add. So if you implement r add just like how you did for addition, you should be able to get the same error, that is the attribute error. Now give it a try. I will start live coding only when I introduce Neuron class, but before that you have to work on this r add. And if you don't implement r add, most of you I see on my right and left behind, they are like happy. The forward people who are seated in the front rows, they'll answer, we'll follow them. If you don't implement this, you won't be able to solve the first assignment for today. So do you see the same attribute error now in case of a plus 2 and 2 plus a? Okay, there's only one person in this room or what? Only he is answering, he says yes, I could see the same bug. What about others? Yes? Okay, you can be louder. So r add is one method you have to implement or override as part of value class. And it doesn't have to be as complicated as the addition method. What you can simply do is take self and other, assume they are of type value and you just return self plus other. You don't have to do typecasting yet, we'll do that later. But the assumption, you can go with the assumption that whatever two values are getting added, both of them are instances of the value class. You can assume that and just return self plus other in r add. So I'll give you the code for that also. This is the simple code you have to add as part of your value where do you think we should do that typecasting? Just think only about the addition operation. Multiplication, we'll do it later. Yes, in the add method. So what do you think is that one line of code fix? Correct, it is in the d_add function, but what is the code change that you would do? Okay, so if it is not of type value, then what do you do? Okay, so how would your line, code line look like? If not integer? Huh. Okay. So he says in a d_addition method, I will check if the other type of the other variable is it of type value or not. If it is not, then I will convert it into value type and then proceed with my addition. So that's how I can deal with the attribute type. So can you do that code change? Meanwhile, I will also try to fix the code. So this is my code. So it is up to whatever you did in exercise 1 yesterday. So I replicated the same thing. So let me rerun the code cells again. So I'm getting input error, type error and attribute error. So I will go ahead and add add here. So I want to keep it below addition method so it becomes easy for me to maintain the code. So def which takes self return self plus other. So when I rerun my code, now both are throwing attribute errors. Up to this point it's done. Now as per your answers, the code changes must happen in add. So what I can do here is, I will typecast the other value. So for that I can quickly do value of other, assuming it's float, int or any other data type, but I want that to be in the form of value. So let's see what happens with this. So my first code cell a plus 2, it's fixed. Coming to 2 plus a, that is also fixed. But this line of code is slightly not efficient, because in case the other is of type value, I still don't want to do a typecasting. Only if it is not of type value, then I will do a typecasting. So I'll just have a inline if else condition to do that. So other will remain the same in case the type is of value. For that what I can do is equal to other if is instance else this. So I think this is syntactically and logically correct. It should work. So let's try. Yes. So it's working. So I made this one line of code change to deal with typecasting. So this is, we did it for addition method. Similar code applies in the case of multiplication as well. So multiplication I won't do it, you can do it as part of the exercise. But make sure that the addition is fixed. The R addition and the normal addition. You have to include R add method and you have to make this tiny code change in addition. So if you have doubt on where is this is instance coming from, you can look up for the documentation, you will find it. What are the arguments it expects and what does it return? Is it boolean, is it int value, what is it? You can look up for that in Python documentation. So commonly used method. So I think most of you have completed this code. So let me switch to the other monitor. So we fix this error now with the help of, so to fix this type conversion we chose addition multiplication. We understood the fix has to happen there. And the code that we added is this, in case you haven't made a note of the code. Now the second task or a short task that I want you all to do is change the representation. Remember we have a d_ method to handle the representation of the value object. We have d_repr. So in that we just say, or we are returning a string with value which holds the data. But I want you all to include the gradient value as well, because it will be helpful to look at the gradient values in tomorrow's session. Today we deal only with forward pass, but tomorrow when we do the backward pass, the gradient values will be easy to look up. So go ahead, please change the representation method, include the gradient value as well. So this is a simple code change. I am showing you the code that you have to change. So make sure you are including the gradient value also. Meanwhile, I will also make sure my practice notebook is in line with your code changes. So this was to give some finishing touch to our value class before we proceed including this in a neuron class. So we did some few quick fixes so that we can use it without any errors or without any bugs along with our neuron and layer class in today's session. So coming to the next part, I want a few things to be very clear in your mind, because you might get confused between what's the difference between the value class and neuron class. Neuron class I'll be talking about it in some time, but make sure that you understand the difference clearly. So value class has neurons data, it has the gradient value of a particular neuron. So these are two values we are storing. Apart from that, what do you think are we doing in the value class? Backward propagation, part of it, yeah. Accumulating gradients, we are having that logic, correct? So we are calculating, we are also accumulating the gradients. So to put it visually, what I did is I have two diagrams, one diagram where I am using two colors, that is red and black, so it's easy for you to visualize. So this circle in black represents the value class. So where do you think is a neuron class? Is it a subset or a superset? What do you think it should be? Do you think there can be anything else done further in depth in the value class? Or that's it? It's like the bottom, we can't do anything further. Just a guess. Do you think we can decompose the code that we have in the value class further? Or it's fine? It's fine? Okay. In that case, our neuron class that we are going to implement in some time becomes a superset, or it's going to use the value class somehow. I'll show you how it's being done, but understand that these two classes are different. Value class, you can think of it as the finest class. At the most granular level, you are dealing with the data, whereas neuron class is slightly abstracted compared to the value class. That's the reason I included this diagram, so that you understand it visually. You get a mental picture of where does my neuron class stand and where is my value class, and what value does it hold. So far we dealt with value class, all good, but you did so many exercises in week 1 and week 2, that is on day 1 yesterday, and most of it you are initializing weights, biases, input data manually in one of the cells of the notebook. We did not automate it, right? So neuron class is something we are going to introduce in order to automate this process. That is initialization of weights, bias, taking the input and performing the forward pass. Up to that point is what the neuron class is going to do. So neuron class, it uses value class again, because the data initialization we do it with the help of value class, and we automate the assignment of weights and biases using neuron class, and we also implement the forward pass. That is nothing but applying the activation function on the sum of all wx plus b's. So up to this point is the duty or the responsibility of the neuron class. Now this is like a pseudocode, you can think, or what my neuron class should look like. Now let's proceed with the implementation. I hope I'm not revealing the code. Let me check once. Yes, so I'm not sharing any code here. Now it's time to implement the neuron class again in the practice notebook, where you have the value class already implemented. We'll use the same notebook for neuron class, and we have to pass input values somehow to this class. We have to initialize the weights and biases randomly. Remember, because in ANN on day 1 I told you that we start at a random state, assuming that it's going to give us the least loss error. Then we proceed with the forward propagation, take the feedback with the help of loss function, and then we do a back propagation, and then we try to reduce the overall error. So today, neuron class, we understand how that randomness is initialized in the form of weights and biases. And then we also calculate the activation output. Remember, because there are two intermediate outputs that we have. First, we calculate the sum of wx plus b, we pass it to tan h or any other activation function. For today's class, we still stick to tan h, but in the other sessions, maybe you have to use another activation function. So this output has to be generated. Up to this point, our neuron class should have all the methods implemented. So now let's implement neuron class in practice notebook using the same notebook. And why is this getting repeated? Okay, this I can show it to you later. So I will also switch to the practice notebook. So make sure you have the import of math and random, because I'll be using this library random for random initialization of weights and biases. So now what is the goal? I'm taking this cell where I want to implement the neuron class. So please follow the same steps. It's important for the assignment. I think that's the only way I can lure you guys to start coding. Class, neuron, that is the name I want to give. Now, as per my target or goal, I need to initialize the weights and biases randomly. So for me, I would like to put that code or logic in the init method, because that deals with the initialization of attribute variables. So init w comma b randomly. So for that I utilize the d underscore init method, and what does it take? First, anyway itself. Next, how many values should it initialize? Weights, correct. I think bias is anyway 1. So how many weights should it initialize? How do we decide that number? Number of values, input values, yes. So number of weights that we are going to randomly initialize should be equal to the number of input values we have, that is number of x values we have. So somehow we have to get this number. So I will say neuron input, NIN is the variable name I would like to choose, the argument name. Now this is, I have to initialize the weights first, and for that, since this weight value is not 1, that's the reason I prefer to put the weight values in a list. So I open this square braces, self.w, and again I will use the value class here because I want everything in the form or type of value. So in the value class, now I use the random method, random dot uniform So I pick any values from -1 to 1 range, and I make sure that they are all of type value. That is exactly what this piece of code is doing. But this is still incomplete because this is like initializing only one value. I need to have multiple values depending on what is the value that I receive in NIN. So for that I use for loop inline. So I say, or I command my Python code to initialize random values for underscore in range NIN. So I am instructing my Python code to initialize the variable list randomly, typecast it to the type value, take the values in the range of -1 to 1, and you do it as long as the count of NIN is not equal to 0. That's the reason I'm using a for loop, which is inline. And do you know why did I use a underscore instead of having a variable name there? This is a commonly used convention in Python. I can choose X, I can choose I, because in Java or C++ we do it right using int I or X, right? So why underscore? Name is not important, okay. That is partially right. Any other answers? Name is not important, and also that variable is not important. That is to indicate that this is a variable that I immediately dispose of. I won't be reusing it. So this is again to enhance the readability of the code, comes under the good practices in Python. Now my weights are initialized randomly depending on the count of input variables I have. Now there we have to initialize the bias also, and this time again randomly, but this bias is only one, not multiple. So I will take this code, paste it here. Oh, it's working for me. Does it work for you in practice notebook? No? So you have to type it then. So this is the basic init method. There's one more method, I'll show it to you in a moment, but let's make sure that this is running. So what I do is, I will try to initialize a variable of type neuron. For testing, I decide that they are going to be only two weights or it's a two-dimensional neuron. And now let me check what is the length of n dot w. It says 2. I will also print this and see what happens. So good, it's returning me two different values. If I rerun the cells, the values change. Rerun it again, the values change. That's because we are using random function. Do you know how to control the randomness? Seed, correct. So I will choose any random seed just to make sure that my code is consistent and probably I want to verify it later. So I will choose a random seed. Random dot seed 1 2 3. You can give any other value. So rerun this, I get minus values, rerun it again, I see the same values. That's because I am setting the random seed to 1 2 3. This is all good, but our target is only partially met because this is the random initialization. But for forward pass, we need to do something else. So what do you think is missing? Summation, yes. Summation and also applying the activation function is missing. So that is what we are going to implement next. So in it, random initialization of variables done, all good. There are no code errors. Now my next target is to have a callable method to do this, that is tan h of sum of all wx plus b. So I want a callable method which does this work for me because I initialize the variables, weights and biases randomly. Next I have to proceed with the summation and application of the activation function. So for that I use a method which is called d underscore call. And what should it take? Self. And what do you think is pending? We initialize WB, but is there anything missing in the entire picture? Input values. The X values are missing. So let's have those X values taken here, or we are handling the X values here. So I make this a callable function and now I will say act is equal to sum of all, but this is going to be slightly complicated. Okay, let me go ahead do this. Sum of all wi xi, but it has to come from this list. Where are these wi xi coming from? In. So what do you think the logic should be here? Let's say you have 3 inputs and 3 weights. So which function in Python do you think will be useful here? I don't want to use for loop again. There is one out of the box method that Python provides. Yes, any answers? Zip, yes. So we'll use zip so that we can combine both the lists in corresponding format. Zip of self dot w comma the x that I am receiving. So logically what I wanted to do, sum of all wx is there, but b is missing. So there is a way of including self dot b to begin with. You can look up for the method sum in Python, you will understand why this is working. So this is to indicate the summation method that we begin at self.b and keep adding the values from here incrementally. So we don't start at 0, 0 is the default value that the sum method takes, but self.b is indicating that we don't start at 0, whatever you add start from self.b. So self.b plus w1 x1 plus w2 x2 plus w3 x3. That's how this method is going to work. So this is again partially done. The next step, I have to apply my activation function. So let's say out is equal to, so what do you think I should be calling here? Tan h, should I be taking that from numpy? From numpy? Value class, yes. So we don't deal with tan h from numpy because we already have tan h in our value class, and we also ensured that these values, whatever we are initializing, wb, they are of type value. So let's do this. Logically this seems correct, but let me see. I think multiplication may throw an error, but let's try it anyway. So out should be act dot tan h, and then I return this value, that is out. So let's run this. So syntax error. Sum of wixi from, sorry, zip. Last int value. No, it says syntax error from, for, right. So now yes, the from was a mistake, for is the correct one because I am iterating over the zipped values. For wixi in zipped values, all good, but how do I call this? So I need to initialize some input data. For example, I would say x is a list of two values, 1.o comma 2.o, because we did not initialize the input data anywhere. Now ideally this has to come from the data set. Now since we are understanding how neurons work, we will go ahead with this input data. So x equal to 1.o, 2.o, and we chose that the dimensionality or number of weights should be equal to the number of elements in the input list. So that's the reason we still stick to neuron of 2. Now this is going to initialize, all good, but how do I call this method? N of x, correct. So this returns an out, so we should be able to see some kind of output. Yes, so as expected this is throwing an error. Float object has no attribute data. Remember, because we fixed only the addition method, we did not fix the multiplication method. So I have to handle the typecasting in multiplication method too. So for me it's convenient, I will copy and paste the code here. Rerun, neuron class, right. So there are two changes that I did here. One, I implemented this callable method. Second, I also handled the typecasting in multiplication method of my value class. So you read that error, you will understand where the fix has to be done, because we fixed it in addition method already, right? So up to this point, do you have any questions, or do you want me to display any part of the code specifically? So I will keep the neuron class open for a few minutes. You're taking picture, that's fine, but type please. So 2 more minutes, make sure whatever code changes we did so far is working at your end also. After that, we proceed with the exercise 1 for today. Alright, so we'll proceed with exercise 1. I did not release the notebook yet. I will give you a quick description on what is there in the assignment. So we implemented the Neuron class. We made sure that we have a way to pass input values to our Neuron class. It's done. We are able to call the Neuron class with the help of input values, and we are able to initialize the weights and biases randomly. That also we have implemented, and we are calculating the final output, that is applying activation on the summation of Wx plus B. Up to that point, it's done. Now to give you a visual understanding so that it's easy, if you can think of this as a Neuron class where the left part of the hemisphere or the right part of the hemisphere, it has sum of Wx plus B and then it has an activation. You can think of the Neuron class this way. So where is your value class? So value class is going to be like a helper class in order to deal with the operations, that is addition, the forward pass, accumulation of the gradients, etc. So that's being dealt by the value class. So you're still having dependency on the value class, though you implemented Neuron class. So in the Neuron class, you're doing a sum of Wx plus B and you're also applying the activation on it. But all that is possible because you have the value class in the first place. So this is to give you a mental picture of how value class and Neuron class are working together. Now coming to the first exercise, it is very similar to what you did in the class, but the values are differing slightly. You have to do a forward pass using the Neuron class, and there are a couple of code snippets which are missing in the value class. So you have to fix the code there, you have to fill in the missing code in the value class. After that, when you call the Neuron class using the callable method, you should be able to see the correct output. So for that we have visible test case also. There is a random seed that I initialized as part of the assignment. So make sure that you're not overwriting or modifying that random seed, because the assertions will fail in that case. So there's one visible test case and one hidden test case. I'll release the notebook. So do you see the week 2, day 2 exercise 1? Not yet? For me it shows assignment published and generated successfully. Can you recheck now? So this is exercise week 2, day 2, exercise 1. Okay, I have to click on start. My bad guys, I just missed clicking on start. Now I think you should be able to see this. Yeah. So this is the student view at my end. I can see DL week 2, day 2, exercise 1. If I do a fetch, here's my assignment notebook. Yes. So this is slightly lengthy description, but exactly what we did in the class, what I explained and what you all did together. And here you can see that the value class, I'm giving you the boilerplate code. I also modified the representation method. But what is missing here is in the D underscore addition, you have to handle the typecasting. And similarly, and also the accumulation of gradients, this logic has to be implemented. You did it as part of exercise 1 yesterday. So you can replicate the same code here. And for D underscore multiplication method also, you have to handle the typecasting, accumulate the gradients. And for tan h, the backward method or the accumulation logic is not there, you have to implement that. Remaining, I have provided some additional code, that is D underscore negative, R add, subtraction, R sub. So you can take a look at it when you have time. And now comes the main part, that is the neuron class. So I am giving you a description of whatever steps we did in the class activity. And here is the assertion cell. So I am just defining a random seed here. I am saying that the input values are of length 4 and these are the values. So I am calling the neuron class, you don't have to write this code, with 4, and the output I am storing by calling n of x. So the final output that you are going to generate with the help of neuron class has to match. So these are the two values I am verifying. We have a similar test case in hidden test code also, but few things have been changed. So if you have any questions, please let me know. 15 minutes should be good enough for this code, right? Or do you think you need slightly more time? 5 more minutes, we'll close this exercise. It's quite simple. So we can deal with layer exercise, the next part of the session. Unlike yesterday, I will be closing this exercise before I open the next exercise. So make sure you complete this exercise in another 5 minutes. So most of you have completed this exercise, right? Anyone yet to submit? Please raise your hand. How many more minutes will you need? 1 minute? 5 minutes? But you already completed most of the code until yesterday. And today's code anyway I gave it to you in the live coding session. Okay, so it's 5:19, 5:22 I close it. Because there's one last exercise that you have to complete. If you complete it quickly, you can leave for home. One more minute and I'll close the quiz, exercise 1. Please make sure you submit it. Alright, so I'm stopping this exercise now. So we just completed this exercise 1, that is to do a forward pass using the neuron class that we learned. And now comes the next step, that is introduction of layers. Because so far it's still like we are dealing with a single neuron. Not much is happening with multiple neurons. So by introducing this layer class, we introduce multiple neuron concept. So we again go layer by layer so that it's easy for you all to understand and implement. So in this layer class, we'll have multiple neurons. So whatever we did so far using one neuron and its corresponding value class, we'll be doing that with the help of layer class and multiple neurons. So let's see what all are required. Value class, we already completed this. Neuron class, we already implemented this one. So far so good. And we did not introduce layers. So it's time to implement layers. And our final goal is anyway to mimic how an MLP or an ANN gets trained. again this layer class internally will be using neuron class and it has a dependency on value class. So layer class has dependency on neuron class as well as value class, whereas the neuron class has a dependency on value class. So that is how the hierarchy is, and today we will do it, the implementation of the layer class. Now what has to be done as part of this implementation? We need to initialize neurons based on the dimensions we pass to it. So we have a list of input data values, and we understood that with the help of neurons how we can randomly initialize weights and biases. Now it is like stacking neurons multiply, like one above the other in a layer with the help of layer class, because we want to introduce the multiple neuron concept. So that's the reason we are introducing multidimensionality with the help of layer class. And we have to create layers based on layers count passed to it. So we will decide how many neurons have to be there in a layer, and later we will also see how we can combine these multiple layers together. But in today's session we will see how we can have multiple neurons in a single layer. And we have to do a forward pass using all the neurons in that particular layer. Now this is for visualization again. In red is the neuron class, which is still using value class, and we are saying that the layer class has to deal with multiple instances of such neuron classes. So layer will look like this, a final composition. So this is for your visualization. You can draw it on paper, and you can also see how the values are being exchanged between these various classes, between layer, neuron and the value class. So now, okay, before we jump to exercise 2, we will go back to the practice notebook. So coming back to where we had left off, so we introduced the neuron class. Up to this point the code is ready. Now the target is to have a layer class, layer. So please follow this code, implement it at your end. Now there are two targets, right? I need to define the dimensionality, that is how many inputs are there and how many neurons do I need in a layer. So basically there are going to be two values that the layer has to deal with. That is how many input values are there. Let me call it NIN, number of input values, and then there is another thing NOut, that is number of neurons I want in a layer. So these are the variable names of my choice. So let's go ahead and implement this. So the first method anyway is going to be for initialization. So in the initialization step, I need to initialize what? Initialize value class, neuron, yes. So in the layer, when we are calling initialization, we are initializing neurons. And how are we initializing those? So we are taking two arguments, NIN and NOut. NIN is to define how many input values are there. This value has to be passed to the neuron class, right? That's where we are initializing W and B. So we need to know the count of inputs, how many input data we have. So that is, we are taking from this argument NIN. Now NOut is my choice, how I want to compose this neural network. How many such neurons do I want in a particular layer? So that is the NOut value, we capture it using this argument. Now coming to the initialization step, I need to initialize the neurons here. So I choose to name it as neurons. So this is a class attribute, and this is again going to be a list. But this time, as you mentioned, this is going to be a list of neurons. And what value should I pass here? To neuron class? NIN, correct. And how many such neurons should I initialize? N out, correct. So these are the number of neurons I want to initialize, and each neuron will be dealing with 2 input values. So let's see whether this initialization is working correctly or no. I have to run the cell. In is missing. So now let me say X is again the same thing. I will take it from the previous cell. We are not using X yet. I want to keep it here for reference. Now I say L is equal to layer, and how many values should I pass to it? NIN, what is the NIN value I should pass? X is the NIN value? 2, correct. Because in my list of input, I have 2 elements. So the length of input is 2. That is equal to the NIN value. Now N out is our choice. How many neurons do we want in a particular layer? For simplification, I would choose 3 because I don't want to verify too many neurons at the moment because computation will take more time. Now let's see what is being returned. L dot neurons, because this is what we are initializing here in the init method. We are initializing neurons. So let's see what this returns. So it is basically creating a list of different neuron instances. Done up to this point. I'll show the code again. This is not needed. So these 2 cells of code, these 2 cells, the layer with init method, and then you just initialize and verify whether the neurons are getting initialized correctly or not. Done? Now, how do we do the forward pass? That is pending. We implemented that in our neuron class, but where is it getting called? Callable, call function, okay. So we can define that def. Let's make this also callable. So self, and what does it take as input? X, correct. So callable of the layer class also takes X as input, but the implementation differs here. And what do you think should happen here in this callable method? Look at what did we do in the neuron class. This cell. Just look at this cell because this is at 1 neuron level, right? 1 neuron at a time. In layer, we are just stacking the neurons. So for the forward pass, which method should we call? I agree we have to call this callable method of layer class, but in the implementation, what should we be doing? N of X. So he says self dot neurons of something and then X, right? So let's do it. Again, we'll use the iterator here. I choose to call this output as outs because we have multiple output. This is going to be a list of outputs. Remember, we have 3 neurons, and I'm deciding that it's going to have 3 neurons here. That's how I'm defining this layer to be. So now we have to call the forward pass, and the forward pass logic is not in the layer class. It is here already defined in the neuron class. So somehow we have to call this method from here. And for that, I just have neurons with me. So I have to go 1 neuron at a time. So how will I do it? I will say for something is missing here. Let me put it as question mark. But for n in self dot neurons, right? Because I am initializing neurons here, they are there 3 for now because I defined it as 3. So I am iterating over this list of neurons and now I am calling it as n in the list of neurons, and I have to call the forward propagation logic here, the forward pass, n of x. And why do I choose this n? Because it's easy for you to understand. We use the same naming convention in the previous cell. So whatever we did with a single neuron, we are doing it with multiple neurons here. Now we have to return outs. So let's run this cell and see. Logically it seems right. And this time there is one step that is missing. What is it? L of x, correct. Alright, so I see this value. Now it's returning, it's calculating this value, that is sum of all wx plus b, applying the activation function on each neuron, and then it's returning me the final list. Now you can change these values and play around with it a little more. So if you are taking 3 input values, then you have to change this to 3 because you are indicating to the layer that each neuron will be dealing with 3 inputs. And I can change this to 4. Let's see how it works. Alright, so it's giving me the correct code. So there are no errors. Similarly, you can change the values and see how it works. It's basically we are increasing the dimensionality of our code. We are introducing the multiple neuron concept here. Up to this point, you have the code ready, the layer class as well. Okay. So I see a couple of you nodding your heads. So we are good to start with exercise 2, which is quite similar to what you did in exercise 1. Again, we will be testing whether you understood layer class correctly or no. So I will release this second exercise, which is the last exercise for today. So publish and we start. So you should be able to see DL week 2 day 2 exercise 2. So let me verify that. It's here. Okay, so here's the notebook, week 2 day 2 exercise 2. So it's quite similar to exercise 1, the value class completely I have given you. So there's nothing to do in the value class, no missing code. You have to focus on the neuron class, fill in the missing code, and then you have to implement the layer class. So once that is done, your assertions should pass. Quite simple, we're just introducing the layer class, nothing else.